Alright, in this video we will continue our work on graphing rational functions with all the fixins, vertical asymptotes, horizontal asymptotes, slant asymptotes, holes. We'll talk about whether or not the function is continuous or discontinuous. Let's take a closer look. Alright, it's actually easiest to start with the horizontal asymptote. So look at the degree. Since the top degree is less than the bottom degree, we know that the horizontal asymptote will be y equals 0. Okay, that's the rule. You can't have a horizontal asymptote and a slant asymptote. Alright, you only will have a slant asymptote when the top degree is higher by 1. So put none for slant asymptote. Now for the vertical asymptotes and the holes, we need to factor and take a closer look at what's going on. If anything cancels out, it'll be a hole. So this factors a little bit. Here there's not much I can do with my x to the 5th power, so I'm just going to write that down. But down here there's a common factor, GCF. The greatest common factor is x. If I bring that out, then I've got x to the 5th power minus 1. Okay, so normally I would look at these two factors and set them equal to 0, and I'd be thinking I have two vertical asymptotes. Okay, in fact, let me just follow through and do that. So normally I would go, hey, look, I have two factors. I'm going to set them both equal to 0. So if I set this equal to 0, that just gives me x equals 0. If I set this equal to 0, then I would want to add 1 to both sides. So that's going to give me x to the 5th power equals 1. But then I would want to take the 5th root of both sides to get rid of the power, the exponent. There's no plus or minus when you have an odd root. Okay, so then that will give me x equals 1. Alright, and normally I'd be thinking these will both be vertical asymptotes. However, this one, the x equals 0, well, this x right here is going to cancel out. Okay, the reason why is because, you know, x to the 5th power, you can think of it as x times x times x times x times x, right? It's x to the 5th power. So you can easily see that the x right here in the denominator will cancel out one of the 5 x's. So I'm still going to have x to the 4th power up there. Alright, but that cancels out. Now because it cancels out, that means instead of this being a vertical asymptote, this is going to give me a hole at 0 comma something. Alright, so I'm going to have a hole at 0 comma something. X equals 1. Alright, this didn't cancel out, so I do have a vertical asymptote at x equals 1. Now if I want to find out the y value of the hole, and I do, then what I need to do is I need to put this part of the function, the part that did not cancel out, put that in my calculator and see what the y value is. So see, I have my 4 x's. I'm just going to put this back to x to the 4th power. Okay, so x to the 4th power over x to the 5th power minus 1. Okay, so this is how I would type that in. And then might as well just start at 0 since that's what we're interested in. Okay, so I've got 0 comma 0. Alright, so that's the hole. So if we go ahead and graph the asymptotes and the hole, alright, so I have a vertical asymptote at 1 and a horizontal asymptote at 0. That's going to look like this: vertical asymptote at 1, horizontal asymptote at 0. Now we have a hole at 0 comma 0. You're going to record the hole as an open circle. Now, it might be bothering you that we have this hole on the asymptote, but it shouldn't be bothering you. For one thing, a hole is an empty place, and an asymptote is very often also an empty place. So, worst case scenario, it's just an empty place. But we have learned that a horizontal asymptote is all about end behavior. You can cross over a horizontal asymptote. It's all about, in the end, the graph will approach it, but you can cross over a horizontal asymptote. So that very well may happen. In fact, it's time to go ahead and form a table of values. So let's, we've already got the function in our calculator. So keep an eye on the vertical asymptote. Alright, because I like to have a few values to the left and a few values to the right. So I already see that we have 0, 0. What about -1? Okay, at -1, we're at -1/2. Okay, so at -1, we're at -1/2. So that'll be a point right there. This is interesting. Alright, let's see what happens really close to the asymptote. So let's see what happens at 0.5. Okay, and a way that I can do that is go back to the table, hit enter. I'm going to go ahead and switch over to ask mode now. Alright, so I can put in just the values I want. So what did I say? I want to know what's going to happen at -0.5. Okay, so at -0.5, is that what I wanted? Oh, actually I want positive 0.5. Okay, at positive 0.5 I have -2/31. That's a really tiny number. Okay, that is less than -0.1. Well, it's closer to 0 than it's virtually on the x-axis. It's a tiny bit below the x-axis. Okay, so at 0.5 I'm a tiny bit below the x-axis. This is really weird, so I still don't really know what's happening. So I'm gonna see what's happening at for example 0.9. Alright, I'm gonna go right up to here because I still don't know, is it going up or is it going down? I don't know. So let's take a look. What's happening at 0.9? Okay, so I'm going to type in 0.9. Take a look. Okay, at 0.9 I'm at -1.6. Okay, so when I'm really close to the vertical asymptote, I'm at -1.6. So now I know that it's coming down. It's coming down. So this is a really interesting graph because it goes up to this 0, 0, and then it comes back down, and it must go down from there. Okay, I'm curious. Let's see what's happening at for example -5. Okay, don't be stingy with your points. Well, look, -4 is already there. So at -4, I'm at -0.2. So at -4, I'm going to be at -0.2, which is like right there. Okay, and it's got to approach this asymptote. So I'm betting at -10, it's still going to be negative something. Let's check and see. So -10 is -0.09. So it's basically -0.1. Okay, so again, that's just barely below. So it's a little bit weird, but this graph must be doing this type of thing. It's a little bit hard to draw too. It looks like it's hopping up for a quick second, and then going back down like this. I didn't mean to pull away like that. It's hard to do. Alright, it should be looking something like that. This is really weird in this area, but what are you going to do? Okay, now let's see what's happening on the other side. Again, I'm going to take a look at decimals to the right. So let's see what's happening at 1.5. Okay, so 1.5, I've got this thing. Okay, that's 0.7, almost 0.8. So at 1.5, I'm at like 0.7. Okay. I'm betting at 1.1 it'll be higher than that. So let's see what happens at 1.1. All right, it's like 2.4. So right up against this asymptote, I'm at like 2.4. So it's clearly going up. All right. And I'm betting that it's going to get closer and closer to 0 over here. So let's see what happens at 2 and 3. All right, so at 2 and 3 and 4, for example. Okay, so at 2, I'm at 0.5. All right, at 3, I'm at 0.3. And at 4, I'm at 0.25. Okay, so clearly it's just hugging the line here. It's hard to draw well. Okay, that's the idea. So, the domain. It's tempting to say the domain would be negative infinity to 1, and then 1 to infinity. But watch out for the hole that's here. Okay, watch out for this hole. So I have to say negative infinity to 0, and then 0 to 1. Okay, negative infinity to 0, and then 0 to 1. Okay, so I know it seems silly, but this is actually in two pieces over here. I've got this piece, and then I've got this little piece right here. Alright, we have to skip over the hole. And then we'll say 1 to infinity for this branch over there. Is 1 to infinity. Okay. Graphs that are unbroken are called continuous. Okay, so a graph like this one is continuous because it's unbroken. Alright, graphs like this are discontinuous. Okay, and if they have asymptotes, those are non-removable. Okay, so, and oh yeah, if you have a hole, that's a point discontinuity, which is removable. So we have both. We have the asymptote, okay, an infinite discontinuity, which is non-removable, and we have a point discontinuity, which is removable. So I'm just going to check off both of these. All right, it's we have a removable discontinuity, which is the point 0, 0. And it's discontinuous with a non-removable, actually two non-removable discontinuities. We have the vertical asymptote x equals 1, and the horizontal asymptote y equals 0. Okay, and that is it for problem number 2. Alright, so I'm gonna stop this video here because it's already 15 minutes long. Alright, I'm hoping it does not take 15 minutes per problem because there are 8 problems, man. It's a lot of time.